Hello, beautiful people. My name is Bins, and welcome back to the Shapez BEASTMAM series. In the previous video, we built a rudimentary version of a one-tick and pulse-compatible clock together. I ended that video on a note that there was gonna be more to it than that. Additional obstacles that come with further parameters we would have to be taking into account. In today's video, we will elaborate on the first of those parameters, and that is quadrant flexibility. So we are still in chapter 4b, but have moved onwards to episode 2. Quadrant flexibility. Now, don't worry if you don't know what the term quadrant flexibility means. It's a term I made up just to describe the nature of our problem. So last episode, we built this basic clock. We provided a way to load a set of values into it, have it cycle through those values and loop around. And then finally, we also added a way to reset the machine when we needed to. Now, let's remind ourselves where exactly this clock fits within the bigger picture, all right? We need the clocks to cycle through all kinds of floating shape pieces in order to ultimately see if any of those combinations allows us to produce the target shape. But this thing, the thing we're currently looking at, it doesn't even allow us to generate those pieces. No, it's actually just a small component of a bigger module that eventually will. So what are we looking at then? Well, this cycler is intended to cycle through the 4 quadrants contained on one layer of the floating piece. At a later stage, we will need 4 of these things to create our first floating piece cycler, but we're not there yet. For today, I want to focus on a different question, and that question is, what if a layer doesn't have 4 quadrants? What if it has fewer? Well, if it has fewer, for example, 3, then I want the cycle to consist of 3 ticks instead of 4. And if we just load up 3 signals instead of 4 in this module the way it currently is, then unfortunately that won't affect the cycle time. Have a look at this. If we, for example, if we take away this second quadrant, we reset the module, and then we load up the values again, like so, and now we start cycling, then you see that we have an interruption. So, oh, there we go. So we get red, nothing, blue, white, red, nothing, blue, white, red, nothing, blue, white, etc. So our cycle still takes 4 ticks, and one of those ticks is fully wasted. Now again, this part is the beating heart of the entire decoder, running iteration after iteration after iteration, hundreds of times, right? So cutting out that 1 tick, if we only have 3 quadrants to check, or 2 ticks if the layer has only 2 quadrants, that's going to make a huge difference in the total processing time. So how can we solve this? I thought about it for quite some time until I suddenly remembered one specific term from math class many years ago. When I was still a youngling. Anyway, that term is the least common multiple. We need this clock to be able to cycle through either 1 or 2 or 3 or 4 values, right? And the least common multiple of those 4 numbers is 12. So what if, instead of creating a cycler with 4 memory cells, I created one with 12? That way, I could load the value as follows: 3 sets of 4 values if the layer has 4 quadrants, like so. 4 sets of 3 values if the quadrant has 3 layers, or 6 sets of 2 values if the quadrant has 4 layers, and finally 12 sets of 1 and the same value if the quadrant has 1 layer. Now remember, at this stage, we don't care about the actual values yet. Conversion comes later. For now, we just want a system that can cope with this flexibility, and this one does. So instead of a cycler with 4 memory cells, I actually created one with 12. There we go, fit it nicely on screen. That's what that looks like. Now, in order to know which of these value sets we need to load into the cycler, we need to be able to determine how many quadrants any given layer has, right? And how could we count that? Well, here's what I came up with. In a first step, I'm going to convert quadrants to layers. So for example, if I connect a piece with 4 quadrants, like this one, then with the help of analyzer units and rotators, I emit a circle signal for each quadrant that I count. Those circles are stacked on top of each other so that in this case, I get a shape with a layer count of 4. If I take a shape with 3 quadrants, then it will look as follows: 1, 2, 3, 4, 5, 6, 7, and we get an output shape with three layers. If we take 2 quadrants, then again 1, 2, 3, 4, 5, 6, 7. So you see this thing, additionally, it is tick synchronized because all of the operations take the same number of ticks. And finally, let's demonstrate that with with a layer with 1 quadrant on it. 1, 2, 3, 4, 5, 6, 7, and we get an output shape with only 1 layer. By the way, this works with regardless of where the layers are, right? So if I change this shape, for example, to this one, which has a different layout, then we will get the same result regardless, a shape with 3 layers. So that's the first step. Now, in the second step, I convert this intermediary shape we've created a second time by means of a layer counter. And the layer counter, well, I've demonstrated that one in chapter 3b. That will convert the layer count to a new code shape. A circle if the layer count is 1, a rectangle of 2, a star for 3, and finally a windmill for 4. And if we connect those 2 modules, we have now created a quadrant counter. So a layer with 4 quadrants will emit a windmill signal. A layer with 3 quadrants will emit a star signal. A layer with 2 quadrants will emit a rectangle symbol. And finally, 1 quadrant will emit a circle value. And now we can start piecing it all together with the help of chains of comparing units. A windmill symbol will equal 3 sets of values. So let's connect that like so. A star symbol will equal 4 sets of 3 values, like so. A rectangle will equal 6 sets of 2 values, like so. And finally, a circle will equal 1 value 12 times. Now let's connect that all up. And And there we have it. So a flexible clock with 12 memory cells that is now capable of loading up different sets of values. So let's demonstrate that again. A piece with 4 layers will be converted into white, blue, green, red, white, blue, green, red. Right, so if we load that up, why do we have a conflict here? Oh, because we haven't reset this module. So we load that up. Excuse me. Oh, sorry, made a mistake. Let's fix that. There we go. 1, 2, 3. Do we need another one? No, we're good. Okay, so a new demonstration. We load that up, and now we get red, green, blue, white, red, green, blue, white, red, green, blue, white, etc. A set of 4. Let's reset it again. Try a shape with 3 quadrants. Load them up. Now we get green, blue, white, green, blue, white, green, blue, white, green, blue, white. Okay, that's good. Now, reset again. Shape with 2 quadrants. Load it up. Blue, white, blue, white, blue, white, blue, white. And finally, just the single quadrant. Reset it. White, 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 white. Well, it doesn't matter what we do now because we only have the one value, okay? Now, there is a final thing I would like to do, and that is, obviously, if we have a new set of values, so if this shape changes, I want the new values to be loaded up automatically. So how can we do that? As a matter of fact, we don't need this button anymore, because now we are going to connect this output line right here. We're going to connect it to that line directly. Let's see, does this work? So if I change this, no, it doesn't yet work. Let's see why that is. So this signal moves through. Right, and it still creates a conflict. So what I need to do first is, as a matter of fact, connect this to the reset thing. So we also get rid of this button. And then we are going to connect it like so. Will this work then? Let's try a new shape. Yes, that will work. Isn't that splendid? Okay, try a shape with 3 layers, 3 quadrants. That works perfectly. Shape with 2 quadrants. There we go. And finally a shape with 1 quadrant. And it loads them up. It resets the machine and then loads the new values into the system. So I am very happy with the way that demonstration worked out. So anyway, it doesn't really matter. You can see our cycler module has already become a lot sturdier since we started this episode, and there is more to it. Let me tell you, the rabbit hole goes deep, but for today, I think this should actually be enough. So as always, I want to thank you very much for watching. I hope you had a good time today. Maybe you'll take away a thing or two from this that you would want to try out in your own machines. And finally, if you enjoyed, be sure to leave a thumbs up, leave a nice comment, subscribe to the channel, hit the bell icon if you want to stay in the loop, all that good stuff. So for today, I want to say this is a wrap, I think. I am signing off. So all of you have an excellent day. Bye.